Today we're starting a new unit on ratios, and before we really start that, we need to know what a ratio is. A ratio is a comparison of two or more quantities. Now, an example of a time when we might use a ratio would be if, let's say, we wanted to mix some paint and we wanted to make purple paint. Well, you can make purple paint by mixing red paint and blue paint. So let's say that I knew that I wanted to use 2 pints of red paint and 3 pints of blue paint. So if I were going to use 2 pints of red and 3 pints of blue, then I can have a comparison that says that I'm using 2 parts or 2 pints of red and 3 parts or 3 pints of blue. And so even if I wanted to make, so together that would make a total of 5 pints. But if I wanted to make more paint, then I could say, well, I really want to make double that amount of paint. So if I wanted to do that, I could double the amount of both of those paints and say, well, I'm going to then need 4 pints of red and I'm going to need 6 pints of blue. That would make the exact same shade of paint, and the reason it would still make the same shade of paint is because I still have the same amount of red when compared to the amount of blue, because I have 2 pints of red to 3 pints of blue, which is equal to 4 pints of red and 6 pints of blue. Not the same amount of paint, but the shade would be the same because I doubled both amounts. So a ratio, when I write a ratio could be written 3 ways. So I could write these ratios as the ratio of red to blue. I could write it 3 ways. I could say the ratio of red to blue is 2 to 3, written just like that. I could say 2 to 3, written like that. And I could even write it like that, where it looks like a fraction. It's not the same as a fraction, but it looks like a fraction. So those are 3 ways that I could write that ratio. The order is important. I could not say the ratio of red to blue is 3 to 2, because if I did that, then I am mixing up the order of the amounts of the paint for each color. You can simplify or reduce ratios. In this case, I can't, because just like if this were a fraction, 2 and 3 have no common factor other than 1. So this one cannot be simplified, but some ratios can be simplified. Notice that when I look at that ratio of 4 to 6, that can be simplified to a ratio of 2 to 3. That's how I would know that my 4 pints of red and 6 pints of blue is going to make the same color as if I use 2 pints of red and 3 pints of blue. I'm just going to have a different amount of paint. So let's look and see if we can write some ratios to describe the shapes that we see in this example. If I wanted to write the ratio of hearts to stars, I would look and I would count and I would say, well, there are 1, 2, 3, 4 hearts, and there are 1, 2 stars. So that ratio is 4 to 2. I can also write it with a colon, 4, and the colon, and then the 2. And I could write it where it looks like a fraction. Notice, because it looks like a fraction, that makes it really easy to see that this one can be simplified. So I can simplify 4 and 2. I can divide both of those by 2. And when I do that, I'm going to get a ratio of 2 to 1. Notice I do not just make that the whole number 2, because a ratio has to have at least 2 numbers in it. So I can't simplify it to a whole number like I would a fraction or something like that. These are not exactly the same as a fraction, but we'll talk about in a minute why they are, or how they are and how they aren't like a fraction. So now what this means is then for every 4 hearts there's 2 stars. So in my group there's 4 hearts and 2 stars. Notice if I simplified that, I could say that for every 2 hearts there is 1 star. And I can show that if I wanted to by saying, well, for these 2 hearts there's 1 star. And for these 2 hearts, there's also 1 star. So for every 2 hearts in the group, there is 1 star. Notice I didn't do anything with the moons because the ratio doesn't say anything about moons. All right, now if I wanted to look at the ratio of stars to hearts, notice I'm comparing the same 2 shapes, but I'm comparing them in a different order. So that's going to change the order of my ratio. There are 2 stars, and there are 4 hearts. So the ratio of stars to hearts is 2 to 4, 2 to 4 written with a colon, or 2 to 4 written where it looks like a sort of like a fraction. And I can still simplify that because both numbers can be divided by 2. And when I do that, I'm going to get a ratio of 1 to 2. And what that means is for every 1 star, there are 2 hearts. Well, if you look back up here at my picture at what I highlighted, that's absolutely true. For this 1 star, there's 2 hearts. For this 1 star, there's 2 hearts. So for every 1 star, there's 2 hearts. Okay, let's talk about our next one that says the ratio of moons to shapes. So if I want to look at the ratio of moons to shapes, how many moons are there? Well, there are two moons. So when I look at this, I'm going to write that there are 2 moons. And how many shapes are there? There are actually 8 shapes. And I have to include the moons in that because the moons are shapes too. So that's going to include all of the shapes. It's going to include the hearts, the moons, and the stars. So there are 2 moons and there are 8 shapes. So the ratio of moons to shapes is 2 to 8, which I can write with a colon. I can write in fraction form, and I can simplify that to a ratio of 1 to 4. And I got that by dividing both 2 and 8 by 2. So that means that there is 1 moon for every 4 shapes. And if I look at that, look at this. There's 4 shapes right here, and one of them is a moon. There's 4 shapes right here, and one of them is a moon. So for every 1 moon, there are 4 shapes. Or for every 4 shapes, there is 1 moon. All right, my next ratio is the ratio of stars to moons. So when I go up here and count, there are 2 stars and there are 2 moons. So that's a ratio of 2 to 2. 2 to 2 written with a colon, 2 to 2 when I write it in fraction form. And when I simplify that, that's going to give me a ratio of 1 to 1. That means for every 1 star, there's 1 moon. So even if I made this group much bigger, but I wanted to keep the ratio of stars and moons the same, then if there were 37 stars in the group, there would have to be 37 moons. If there were 12 stars, there would have to be 12 moons. If there were 52 moons, there would have to be 52 stars. There's a 1-to-1 ratio, meaning there's the same number of each of them, same number or same amount of each of them. All right, our last one, moons to not moons. So when I look at that grouping, there are 2 shapes that are moons, and then there are 6 shapes that are not moons because there's 4 hearts and 2 stars, and those are not moons. So that's a total of 6 shapes that are not moons. So the ratio of moons to not moons is 2 to 6, which I can simplify to a ratio of 2 to 6 this way. Or I can write it as a ratio 2 to 6 that way rather. I can write it where it looks like a fraction 2 to 6. And that 2 to 6 would simplify to a ratio of 1 to 3. That means for every 1 moon, there are 3 shapes that are not moons. And for our 2 moons, there are 6 shapes that are not moons. Now, we also need to not only be able to find the ratios, but we need to be able to classify a ratio as to what kind it is. So there are 2 kinds of ratios. There are part-to-part ratios, which compare one part of the group to another part of the group. And then there are part-to-whole ratios. And a part-to-whole ratio compares one part of the group to the whole group. So when you're looking at what you're writing a ratio of, to decide whether it's a part-to-part or a part-to-whole, just look at the 2 things that you are writing a ratio about and decide, is that thing a part of the group or is that thing the whole group? So when we look at our 5 ratios that we just wrote, hearts, for this first one, hearts are part of the group and stars are part of the group. So this is a part-to-part ratio. When we look at the next one, again, stars are part of the group and hearts are part of the group. So this is a part-to-part ratio. For my next one, moons to shapes. The moons are part of my group. For shapes, the shapes included the whole group. It meant everything in the whole group. So this is a part to whole ratio. Now, I want you to think for just a minute about the differences between that and the part-to-part ratios we've done, and we're going to come back to that. Our next one, we're looking at the ratio of stars to moons. And when we look at that, the stars are a part of the group, and the moons are a part of the group also. So this one is a part-to-part ratio. And my last one, moons to not moons. Moons are a part of the group. Not moons are also part of the group. This is one people confuse a lot and think it's a part to whole. It is not. It is a part-to-part ratio. I think people get confused because they look at it and they see, well, moons are part of the group, not moons are part of the group, but together they make the whole group. And I agree with that. Together they do make the whole group, but neither of those is the whole group. They are each part of the group. We're taking the whole group and splitting it into two parts. That's why it's a part-to-part ratio. Now, thinking about the difference between a part-to-part and a part-to-whole ratio, remember that I told you that ratios can look kind of like fractions, but they're not the same thing. Well, that is true with a part-to-part ratio. A part-to-whole ratio is really like a fraction because if you think about this for a minute, the job of the denominator of a fraction is to tell you how many parts are in the whole. And then the job of the numerator is to tell you how many parts we're talking about. So a fraction is a part-to-whole ratio. Just to kind of give you an idea of what I mean by that, if I asked you how much of this circle is shaded, I feel confident you would all say that 1/3 of that circle is shaded, and I agree with that. But let's think about that as a part-to-part or part-to-whole ratio. One part of it is shaded, and the 3 is how many parts, or that's total parts. So in other words, that is a part, the shaded is a part of the group, and the total number of parts is the whole. So when you are writing a part-to-whole ratio, so this one is the ratio really of shaded pieces to all pieces or shaded pieces to total pieces. And that is like a fraction. 1/3 of that picture is shaded. Because again, the job of the denominator is to tell how many total parts there are. The job of the numerator is to tell how many parts we're talking about. You would never look at that fraction and think 1 to 2 or 1/2. But that is a ratio of 1/2 because it's saying one part is shaded and 2 parts are not shaded. So this is, the shaded is a part of the group. The not shaded is also a part of the group. It's not the whole group. So that's the reason, or that's one of the ways that part-to-part and part-to-whole ratios are different. A part-to-whole ratio is like a fraction. It can be any fraction is a part-to-whole ratio. But fractions are never going to be a part-to-part ratio because one of the denominator has to be the whole. So again, fractions are part-to-whole ratios. So some ratios are fractions, but not all ratios are fractions because part-to-part ratios are not fractions because neither of the parts is the whole. So that's kind of maybe helps you understand a little bit the difference between a part-to-part and a part-to-whole, and also this connection to fractions. So there is a connection with fractions, but I caution you to be really, really careful about that. All right, I want you to take a minute and see if you can find which ratio inside the answer box matches those words. So find the ratio of circles to squares, the ratio of circles to triangles, squares to triangles, so forth and so on. Polygons to not polygons, remember that a polygon is a closed plane figure with sides and angles. It can't have curves. So you should be able to look at that and see which figures are polygons and which ones are not polygons. So take a moment and find the ratios and also think about which ones are part-to-part and which ones are part-to-whole ratios. Pause while you do that, and when you are finished, then hit play so you can check your work. All right, now that you've finished, take a look at your answers and see if there are any with which you disagree. and think about maybe where you went wrong with it. I will tell you that there is only one of these that is a part to whole ratio. This very last one, the ratio of triangles to shapes, this one is a part to whole ratio. All of the others are part to part ratios. The one above it where it says squares to not squares, that is a part to part because part of the group is squares and part of the group is not squares. That's different from triangles to shapes. Part of the group are triangles. The whole group is made up of shapes, though. So that's what makes that a part to whole ratio. Now, moving forward, we will start to use some of what we know about ratios to look more at things like what we were talking about at the very beginning when we were talking about this idea of paint. And if we wanted to have a ratio of 2 to 3, how that's equal to a ratio of 4 to 6. And that starts to get into some of the idea of proportions, which is what we're going to be working on next.